Okay, let's dive in. Imagine a black hole, right? But not sitting neatly at the center of a galaxy like we usually think. Picture one, just adrift. A cosmic nomad, a million times the mass of our sun.
And it's been spotted wandering about 600 million light years away. It really does sound like science fiction.
Absolutely does, but it's very real and truly groundbreaking. This whole deep dive is based on a NASA announcement from just a few days ago, May 8th, 2025, and some research that's coming out soon in the Astrophysical Journal Letters. There's a preprint on ArcSieve if you're keen, and Earth Sky did a great report on it.
Right.
And what's so revolutionary here, isn't just another black hole, it's finding one where we just didn't expect it. It kind of forces us to rethink how galaxies maybe form and evolve, doesn't it? Suggests things might be more dynamic. Exactly. More chaotic, maybe. So today we're going to unpack the how. I mean, how do you even see something like that? We'll look at what makes it so unique and the theories about where it came from. And for those of you, say, preparing for exams, maybe UPSC aspirants listening in, this is that cutting-edge science and tech stuff. It challenges the basics of galaxy formation, black hole dynamics. So our mission really is to pull out the key insights and see what it all means.
Okay, so starting with the obvious problem.
Yeah.
Black holes are black. Their gravity is immense. Light doesn't escape. So, yeah, the big question is, how on earth do you spot one, especially one that's wandering?
Exactly. Finding a shadow in a dark room, right? How did they manage it?
Well, this is where it gets really interesting. They didn't see the black hole itself. They saw the aftermath of something it did,
Yeah.
specifically a tidal disruption event, or TDE. It's cataloged as AT2024 TVD.
A TDE. Okay, break that down.
So imagine a star gets a bit too close to this million solar mass black hole. The black hole's gravity pulls much harder on the near side of the star than the far side.
Ah, the stretching effect.
Precisely. It literally shreds the star apart. Astronomers sometimes call it spaghettification.
Ah, yeah, vivid term. Gruesome for the star, though.
Definitely. And this violent shredding releases this incredible burst of energy, a huge flare. That's what they saw.
Okay, spaghettification. Got it. But these TDEs, we've seen them before, haven't we?
We have, yes. Around 100 or so have been spotted, but typically they happen right at the center of galaxies. They basically flag where the central supermassive black hole is.
Right, where you'd expect them.
Exactly. What makes AT2024 TVD totally unique, the real kicker, is that this is the first time we've clearly seen one happening way off center, not in the core.
Wow, okay. That is a huge difference. Completely changes the picture. Who led this discovery?
The lead author on the paper is Yuhan Yao from UC Berkeley. And they pointed out something crucial. They said this event, AT2024 TVD, it's the first offset TDE found by optical sky surveys. And this opens up the possibility of finding a whole population of these wandering black holes we didn't know about.
So one discovery could actually change how we even look for black holes. It suggests there could be many more out there, just roaming.
Absolutely. Yao mentioned that theorists have mostly focused on TDEs in galactic centers. This finding might really push them to think seriously about these offset events, how often they happen, what they imply. It's a whole new angle.
NASA put out an artist's concept to help visualize it. Can you walk us through that?
Sure. It shows the black hole just drifting, far from the galaxy's bright center. Then an unlucky star gets too close. You see it getting pulled and stretched, that spaghettification.
Right.
Then the star's debris forms this swirling disk around the black hole, an accretion disk. As that material spirals in, it gets incredibly hot, millions of degrees, and blasts out radiation. X-rays, UV, optical light, even radio waves.
And that's the flash we see.
That's the flash. But crucially, the illustration shows this flash happening far away from the galaxy's core, out in the suburbs, so to speak.
It's wild to think a galaxy could have two supermassive black holes. What about the host galaxy itself? Does it have the usual one at the center?
It does, yes. Pretty standard for a large galaxy. And that central black hole is quite a bit bigger. It's estimated around 100 million times the mass of our sun, so much larger than the million solar mass wanderer.
Okay, 100 million versus 1 million. And how far apart are they?
About 2,600 light years separates them, which sounds vast to us, but on a galactic scale, well, they're in the same neighborhood, relatively speaking.
Raises questions about their future interactions, I guess.
Definitely.
Now, when astronomers see a big flash like that, how do they know for sure it's a TDE from a black hole and not, say, a supernova, an exploding star?
Yeah, that's a critical distinction. The first detection was made by the Zwicky Transient Facility in California. They scanned the sky for things that change, these transients. But the key was analyzing the light from AT2024 TVAV very carefully. They saw these broad emission lines, signs of specific elements like hydrogen, helium, carbon, nitrogen, silicon on the light spectrum. That was the first clue. It's unusual.
Okay, so the light signature was different.
Right. And then they followed up quickly with other telescopes.
Yeah.
NASA's Chandra X-ray Observatory, the Very Large Array for radio waves, and the Hubble Space Telescope for sharp optical views. The data from all of these across different wavelengths consistently pointed to a TDE from a supermassive black hole, not a supernova.
So a multi-pronged attack using different kinds of light to confirm.
Exactly. And Yuhan Yao highlighted the differences. Supernovae flare up and then they cool down relatively quickly. Their light gets redder. But TDEs like this one, they tend to stay hot and consistently blue for months, maybe even years, as the black hole keeps feeding on the stellar debris.
That makes sense.
Yeah.
A longer-lasting, hotter event. And there's visual proof of the location, too.
Yes, they combined the Hubble images, which show visible light, with the Chandra X-ray data. Overlaying them showed the bright spot, the feeding black hole, clearly offset, distinctly separate from the galaxy's bright center. It nails down the location.
Which brings us to the big mystery. How does a supermassive black hole end up wandering? They're supposed to be the anchors, right?
Okay.
What are the theories?
Good question. There are two main ideas floating around right now. Theory number one involves some gravitational drama in the galaxy's past. Imagine maybe early on there wasn't just the one big black hole at the center. Perhaps there were three.
A crowd.
Yeah. And in that kind of environment, things can get messy gravitationally. It's possible our million solar mass black hole had a close encounter with the other two and basically got kicked out in a gravitational slingshot.
Wow, like cosmic billiards?
Pretty much.
Yeah.
As Yao suggested, it could still be bound to the galaxy, just on a much wider, maybe eccentric orbit.
Okay, so kicked out from the inside. What's the second theory?
The second idea involves galactic mergers. Maybe our wandering black hole wasn't originally from this galaxy at all. Perhaps it was the central black hole of a smaller dwarf galaxy.
Ah, an immigrant black hole?
Sort of, yeah. That smaller galaxy could have been pulled in and merged with the larger one we see now. In that process, the smaller galaxy's central black hole gets sort of stranded, offset from the new center, an orphan within the larger structure.
And what happens to it then?
Well, it's plausible that over long time scales, it would lose energy through various interactions and slowly spiral inwards towards the main, larger central black hole, eventually merging with it.
So either internal drama or galactic immigration. Both are pretty staggering thoughts.
They really are. And the absolute bottom line here, the key takeaway from all this work, is that we now have the first solid evidence, the first confirmed case of a supermassive black hole actively feeding while being far away from its galaxy's center. A true wanderer.
Okay, let's quickly recap. A million solar mass black hole found way out from its galaxy's core, spotted because it tore apart a star. And the main ideas for its origin are either a gravitational ejection from the core involving other black holes, or it came from a smaller galaxy that merged. This is pretty significant stuff, especially, as we mentioned, if you're tracking developments in astrophysics, maybe for UPSC exams or just general knowledge. It shifts our view of how galaxies work.
Absolutely.
Yeah.
And it really does make you wonder, doesn't it? What else is lurking out there? How many other wandering giants might be roaming the darkness, just waiting for a chance encounter, like this TDE, to reveal themselves?
And how will new surveys, maybe even more powerful ones, build on this? Will they redraw our map of black holes in the universe?
It's an exciting time for discovery.
Definitely a fascinating question to ponder. The universe always has more surprises. So if you found this deep dive into the roaming supermassive black hole interesting, please do hit like, subscribe to the channel, and maybe leave a comment. Let us know if you have more questions or what other cosmic puzzles you'd like us to tackle. And remember, the source for today's deep dives was the excellent reporting over at Earth Sky.